Everyone, this is Sinduri from CSCC holding roll number 5G2. Now I am going to explain the topic about preemptive scheduling and dispatcher. Here, what is preemptive scheduling? In real-time systems, the most often used scheduling algorithm is preemptive scheduling. In the preemptive priority scheduling method, if a higher priority process comes in the waiting queue, even if a low priority process is already willing or in the process of transmission, it is halted and placed on hold until the high priority process is processed. The CPU is eventually transferred to the process with a higher priority. This is preemptive because a process that is currently running can be interrupted to allow a high priority process to run. Or in other words, the high priority process will simply preempt the lower priority process. Preemptive scheduling algorithms include round robin, short remaining time first, priority, and others. Here is an example. Let us consider that the process IDs are considered as P1, P2, P3, P4 and corresponding priorities are 0, 2, 3, 1. And here is the table with the process IDs and arrival times as 0, 1, 2, 3, 4 and their burst times has given that 1736. At time t equals to 0 milliseconds, the P1 enters into the waiting queue at time equals to 0 milliseconds. CPU cycle is allotted to P1 since it is the lone process in the waiting queue until another process arrives. So here we can see in this picture that at time t equals to 0 milliseconds, the queue is considered as the Gantt chart and the Gantt chart enters P1 into the waiting queue at t equals to 0 seconds and next t equals to 1 millisecond. The process P1 completes its execution since its burst time has expired and the process P2 enters the waiting queue. Because it is the sole process in the waiting line, P2 receives the CPU cycle until another process arrives. At time equals to 2 milliseconds, the process P3 enters the waiting queue at time equals to 2 milliseconds. The priority of P2 and P3 are now being compared. Priorities 2 and 3 are assigned to the process. As a result, P3 receives the CPU cycle until another process arrives in the waiting queue. P2 has been returned to the waiting line. At time t equals to 3 milliseconds, P4 process arrives in the waiting queue at time equals to 3 milliseconds. The priority of P2, P3 and P4 are now compared. Their relative priorities are 2, 3 and 1. As a result, P3 remains allocated to the CPU cycle until another process arrives or the process quits. Process P2 and P4 are held in the waiting line. And after at a time equals to 5 milliseconds, P3 has completed its execution at a time equals to 5 milliseconds. At its burst time has expired. The priority is then compared between P2 and P4. Their relative priorities are 2 and 1. P4 has been added to the waiting line. And next the time is taken as 11 milliseconds and P2 has completed its execution at 11 milliseconds. P4 is assigned to the CPU cycle since no other processes have arrived and none are left in the waiting queue. And at last the time is taken as 17 milliseconds. P4 is also executed at time equals to 17 milliseconds. And here are the some advantages of preemptive scheduling. Preemptive scheduling achieves flexibility by allowing critical processes to access the CPU when they arrive in the ready queue, regardless of whatever task is presently running. In this case, the CPU consumption is the same. That is, all running programs will use the CPU equally. Preemptive scheduling is also considered fair. It improves the average response time as waiting time is less. When used in a multi-programming environment, preemptive scheduling is advantageous. The drawbacks are processes with lesser priority may starve. The scheduler devotes extra time to suspending the current work, adjusting the context, and dispatching the new incoming task. Scheduling requires high computing resources. And the another topic that we are going to discuss is dispatcher, which is related to the preemptive scheduling. What is dispatcher means? Dispatcher provides control of the CPU to the process picked by the short-term scheduler. When the scheduler finishes its task of selecting a process, then the dispatcher takes that process to the destination state. And here is an example that we suppose we consider the five processes and their arrival times of these processes are T1, T2, T3 and T4, T5. Here we consider the first in first out algorithm is used. P1 comes first and then the scheduler will choose that it is the first process that is going to execute. The dispatcher will eliminate P1 from ready queue and take it to the CPU. Now the scheduler will select P2 which will be executed after P1. The dispatcher removes P2 from the ready queue and gives it to the CPU. This carries on in a similar way for remaining the processes P3, P4 and P5. This is how a dispatcher works, that is scheduler provides the dispatcher will in an ordered list of processes that the dispatcher gives to the CPU. The dispatcher does many tasks such as memory mapping, context switching and setting up user registers. These are some functionalities of dispatcher: switching context, switching to user mode, jumping to the proper location in the user program to reboot that program, managing dispatch latency. It means time consumed by dispatcher is referred as dispatch latency. Thank you.